Welcome back with a new math lesson. Our lesson today about the exponential function. At the first, we'll know what is the meaning of the exponential function, how we can represent it graphically. To start with the exponential function, at the first, the exponential function can be described by an equation which is represented by y equals a times b to the power x, where a is not equal to 0, and b must be a positive number. So we can say that y equals 2 multiplied by 3 to the power x, which represented an exponential equation. Or we can say that y equals 4 to the power x, that's represent an exponential equation. Or we can say that y equals 1 over 2 to the power x. The main point that a is not equal to 0 and b must be greater than 0, must be a positive number. In this problem, we need to graph the equation y equals 3 to the power x. That's the first part of the question. Then we need to find the y-intercept and state the domain and range. That's the third one. Then we need to find the equation of the horizontal asymptote. That is the fourth required. So step number 1, we need to graph. To graph the equation, we need to form the table. The table must be x and y. So we have x and y. Always we use the values -2, -1, 0, 1 and 2. That is the value that we are using. So we need to graph the equation y equals 3 to the power x. So 3 to the power -2 equals 1 over 9. 3 to the power -1 equals 1 over 3. 3 to the power 0 equals 1. 3 to the power 1 equals 3. 3 to the power 2 equals 9. And that is the point that we use. -2 and 1 over 9. That is the first point. -1 and 1 over 3. 0 and 1. 1 and 3. 2 and 9. Then we can graph. So that's how the graph of the exponential equation would be look like. Now number 2. Number 2, we need to find the y-intercept. The meaning of the y-intercept is the value of y when x equals 0. When x is equal to 0, y is equal to 1. So for any exponential equation, the y-intercept will be equal to 1. Now number 3, we need to find the domain and range. What is the meaning of the domain? The domain that the value that you can use instead of x. You can use any number for the power. So we can say the domain is all real number. Now we need to find the range. What is the meaning of the range? The answer that you will find. All of the answers that you find are positive numbers. So we can say that the range will be y is greater than 0. Number 4, the horizontal line of asymptote. Because we are talking about the horizontal line of asymptote, it will be. Because we are talking about the horizontal line of the asymptote, so the equation now will be y equals. We need the equation of the horizontal line, so it will be y equals. Y equals 1. You will find that the horizontal line of asymptote, we have horizontal line is parallel to x and intersect y at the point 0, which is defined by the x-axis. So it will be y equals 0. So always look at the range. We have y is greater than 0 for the range, so the horizontal line of asymptote is y equals 0. In this problem, we need to graph the equation y equals 7x. Then we need to find the y-intercept, state the domain and range, and we need to find the equation of a line of asymptote. So step number 1. To graph, we need to find x and y. We said always we'll use -2, -1, 0, 1 and 2. That is the value that we'll use for graph. You can use any values, but that is the value that we use for graph. Now we need for the equation y equals 7 to the power x. 7 to the power -2 will be 1 over 49. 7 to the power -1 will be 1 over 7. 7 to the power 0 equals 1. 7 to the power 1 equals 7. 7 bar 2 equals 49. Now we can graph. The first point is -2 and 1 over 49. -2 and 1 over 49. -1 and 1 over 7. 0 and 1. 1 and 7. So the graph will be. That's how the graph will be look like. The line is closest to the x-axis, but will never intersect with the x-axis. Now number 2. We need to find the y-intercept. We said the y-intercept is the value of y when x is equal to 0. When x is equal to 0, y is equal to 1. So y-intercept equals 1. Number 3, we need to find the domain and range. We said the domain for any exponential function is r. And the range, you will find that all of the values is greater than 0 are positive numbers, so we can say that the range is y is greater than 0. Number 4, the horizontal line of asymptote. We said to find the horizontal line of asymptote, we need an equation of a line. Equation of a line, horizontal line, so it will be y equal. We said look at the range. What is the value? Y greater than 0, so y is equal to 0. That is the value of the equation of the horizontal line of asymptote. The meaning of the horizontal line of asymptote, the line which is close to the curve but will never intersect with the curve. In this problem, we need to graph y equals 1 over 3 to the power x. Then we need to find the y-intercept. After that, we need to find the domain and range. Then we need to find the equation of a line of asymptotes. So step number 1. We said to graph, always we are using -2, -1, 0, 1 and 2. So if you need to graph the exponential equation, we use instead of x, -2, -1, 0, 1 and 2. 1 over 3 to the power -2 equals 9. 1 over 3 to the power -1 by using calculator, we'll find that the answer will be 3. 1 over 3 to the power 0 equals 1. 1 over 3 to the power 1 equals 3. 1 over 3 to the power 1 equals 1 over 3. 1 over 3 to the power 2 equals 1 over 9. Now we can graph -2 and 9, -1 and 3, 0 and 1, 1 and 1 over 3, 2 and 1 over 9. And that's how we can graph. So we have a difference between the two graphs. Look at the question number 1 and number 2, you will find that b is greater than 1. And for number 3, you will find that b is greater than 0 and is smaller than 1. For number 1 and number 2, you will find that the graph is going from left to right by increasing. It's going up. But in question number 3, you will find that it will be decreasing graph. It's going down. Now we need to find number 2. For number 2, we need to find the y-intercept. Y-intercept is the value of y when x is equal to 0. When x is equal to 0, y is equal to 1. Number 3, we need to find the domain. We said the domain for any exponential function is r, and the range is y greater than 0. Now we need to find the equation of the horizontal line. We said the equation of the horizontal line must be written as y equals. Look at the range. Y is greater than 0, so the horizontal line of asymptote y is equal to 0. Again, the horizontal line of asymptote, the line which closes to the curve but will never intersect with the curve. You will find that the line which closes to the curve will be the x-axis. The equation of the x-axis, y equal to 0. And the equation of the y-axis, x is equal to 0. In this problem, we need to graph y equals 1 over 2 to the power x minus 1. That is the first part. Then we need to find the y-intercept. After that, we need to find the domain and range. Then we need to find the equation of asymptotes. Point number 1 to graph, that's x and that's y. So for x at the first, I will start with -2, -1, 0, 1 and 2. Now by substitution. 1 over 2 to the power -2 equals 4, minus 1 equals 3. 1 over 2 to the power -1 equals 2, minus 1 equals 1. 1 over 2 to the power 0 equals 1, minus 1 equals 0. 1 over 2 to the power 1 equals 1 over 2. Minus 1 is equal to -1 over 2. 1 over 2 to the power 2 equals 1 over 4. Minus 1 is equal to -3 over 4. Now we need to graph. The first point is -2 and 3. That's -2 and 3. -1 and 1. 0 and 0. 1 and -1 over 2. 2 and -3 over 4. That's how the graph will be look like. Number 2, we need to find the y-intercept. We said y-intercept, the value of y when x equals 0. When x equals 0, y is equal to 0. So the y-intercept equals 0. Number 3. If you look at the graph, you will find that we have a transformation. The graph is going down 1 unit. How we know that it's going down 1 unit? Because we subtract 1. If you subtract 1, it means the graph is going 1 unit down. If you add 1, it means the graph is going 1 unit up. So we can find the domain and range. The domain is always for any exponential function is r. But now the range will be different. Because the graph is going 1 unit down, so you will find that y is greater than -1. Just look at this number. You will find that the graph is going 1 unit down, so y is greater than -1. Now we need to find the equation of the horizontal line of asymptote. The equation of the horizontal line, we said it would be y equals, just look at the range. So it would be y equals -1. We have a horizontal line at -1. The graph is close to -1 but will never touch this line. As we said before, if you look at B for question number 1 and question number 2 for the base, you will find that the number is greater than 1. When the number is greater than 1, we have increasing graph. Then we can say that this exponential is defined by growth function. But if the base is greater than 0 and smaller than 1, it will be decay function. The graph is going down. So it will be increasing if b is greater than 1. It will be defined by growth function. And it will be decreasing if b is greater than 0 and smaller than 1. And it will be defined by decay function. Determine whether each set of data are representing exponential function or not. We have two relations connected together. If you add the same number in each time, you are talking about linear equation. But if you multiply the same number in each time, even this number is a fraction or number, it means now you are talking about exponential function. Look at the relation now. Just look at y. You will find that 64 becomes 32. It means you multiply by 1 over 2. 32 becomes 16. You multiply by 1 over 2. Don't say divided by 2. Divided by 2, it means multiplied by 1 over 2. 16 becomes 8. It means you multiply by 1 over 2. 8 becomes 4. It means you multiply by 1 over 2. 4 becomes 2. It means you multiply by 1 over 2. If you look at the difference, you will find that we have different. Difference, it means you multiply by number. Multiply by a fraction or multiply by number. If you multiply by the same number in each time, it means this relation represents an exponential equation. But look at the graph number 2. 12 becomes 16, becomes 20, 24, 28, 32. So if you look at the relation, you need to add 4. 16 becomes 20, it means you add 4. 20 becomes 24 if you add 4. 24 becomes 28 if you add 4. 28 becomes 32 if you add 4. In each time you add 4, it means it's not exponential, but it will be linear relation. So if you add the same number in each time, it will be linear relation. If you multiply the same number in each time, it will be exponential relation. And that's all about the lesson of today.